Hello everyone. Today I will be explaining about MP3 working and also the detailed overview of Huffman coding. So let's start. So first of all the question arises, why MP3 is used? MP3 file reduces the space used by the soundtrack. So MP3 is used worldwide. So now let's start to the roadmap of MP3 working. Here sound wave is converted to the digital signal, which refers to the PCM input. PCM refers to the pulse coded modulation. Then the sound wave is sent to the 32 channel analysis of filter bank. Here it is divided into 32 subbands. So the sound got divided into 32 subbands. Now let's jump to the FFT. FFT refers to the fast Fourier transformation. It converts the sound from time contest to frequency contest. Now let's jump to the psychoacoustic model. As human ears can detect a certain range of frequency only, but sound wave is a mixture of sound. So some of the waves got overlapped by the sound with more decibel. This effect is called masking effect. The psychoacoustic model analyzes the sample sent to it by the filter band, computing the masking threshold in each frequency band using fast Fourier transformation. Now let's jump to the MDCT. MDCT refers to the modified discrete cosine transformation. It works in a sum of cosine functions oscillating at different frequency. After MDCT, sound waves are sent to beat allocation loop to allocate a particular beat. And after that, there is a role of Huffman coding. So let's see. So this is the message. B double C A double B double D A E double C double B A E D D C C. So this is our message. In computer languages, alphabet are introduced in the terms of ASCII value, and the memory storage for each ASCII value is 8 bits. So here total 20 alphabets are there. So in memory storage would be 160 bit. But Huffman coding reduces the memory storage for the particular messages. So now let's see. So I had make a table, character, count of the character and code associated with each character. So total characters are A, B, C, D and E. A is repeated 3 times, B is repeated 5 times, C is repeated 6 times, D is repeated 4 times, E is repeated 2 times in a particular messages. So I have to arrange the repeated character in ascending order. So E first, then A, then D, then B, then C, and their respected repetition number. So E is repeated 2 times, A is repeated 3 times, and then D is repeated 4 times, B is repeated 5 times, C is repeated 6 times. Now I have to consider the least sum. So here the pair would possible 2 and 3. The least sum would be 5. So 5. Now next pair would be possible 5 and 4. The least sum is 9. Now next pair is possible 5 and 6. The least sum would be 11. The next pair is possible is 9 and 11. The least sum is 20. So on the left side of the tree, I have to allocate 0. And on the right side, I have to allocate 1. As you can see. Now, for A, I had a separate 3-bit number like 0, 0, 1. For E, I have separate 3-bit number 0, 0, 0. For D, I have separate 2-bit number 0, 1. For B, I have separate 2-bit number 1, 0. And for C, I have separate 2-bit number 1, 1. So, I had reduced ASCII value, which is 8-bit, to another code which is just 3-bit, and in some cases it is 2-bit. Now let's calculate the size of the message. Size of the code is 3 bit and A is repeated 3 times, so here 9. Size of the code is 2 bit and B is repeated 5 times, so here 10. Size of the code is 2 bit and C is repeated 6 times, so 12. Size of the code is 2 bit and D is repeated 4 times, so 8. Size of the code is 3 bit and E is repeated 2 times, so 6. So total number of bits would be 45 bits allocated to this message. Along with this message, I have to carry this table in our memory. So I also have to calculate size of the table. So the bit allocated with each character is 8, and as there are 5 characters, so total bit would be 40 bits. 5 into 8, which is equal to 40. And I also have to carry code in our table. So the code size is net code size is 12 bit. Now I have to add all the three numbers, 40 plus 12 plus 45. So total is 97 bits. So this is our code snippet for Huffman coding, and we had used different STL libraries here like map, set, and many different libraries. And this is our final code to store the message. Now let's see the output. So we are printing one message here. So this is our message, and this got encoded in different bits, you can see, and this is whole encoding of the message.